Next, let's talk about the inverse cosine of x. So first, let's graph the cosine of x. The cosine of x, remember, we had to limit it between 0 and pi. And at 0, the cosine of 0 is 1. The cosine of pi halves is 0. And the cosine of pi is negative 1. And it looks kind of like, sort of like that. The inverse cosine of x, then, would reflect so that 1 pi halves turns into, 0, 1 turns into 1, 0. Then pi halves 0 turns into 0 pi halves. And pi negative 1 turns into negative 1 pi. So that it looks kind of like that, except they would cross here at y equals x. Okay, now domain and range. The domain of pi is from 0 to pi, so 0 is less than or equal to x is less than or equal to pi. The range is from negative 1 is the lower bound and 1 is the upper bound. So negative 1 is less than or equal to y is less than or equal to 1. Now, the domain and range of inverse cosine. So on inverse cosine, you just switch. So the domain is now negative 1 is less than or equal to x is less than or equal to 1, from negative 1 to 1. And the range goes from 0 up to pi. Cool, cool. Now let's do the derivative. Y equals the inverse cosine of x. And I'm going to take the cosine of both sides. Okay, cosine of y is equal to, cosine and inverse cosine cancel each other out, so we're left with x. Now I want to take the derivative of both sides in terms of x. Derivative of x. Okay. The derivative of the cosine of y is negative sine y, and then the derivative of the inside is y prime. The derivative of x is 1. To isolate y prime, I'm going to divide both sides by negative sine of y, by negative sine of y. So y prime equals 1 over the negative sine of y. Huh, interesting. What can we do with this? Well, let's find out. First, what if this equals 0? Oh no, right? What if it equals 0? Well, let's check. Remember that y is in between 0 and pi. 0 is less than or equal to y is less than or equal to pi. Okay, now let's think of this in terms of some angle theta instead of y, because it starts getting confusing. Okay, so I have some angle theta on the unit circle. My unit circle needs help. Okay, I have some angle theta on the unit circle, and theta is in between 0 and pi. So theta is all this stuff. And we're interested in the sine value of theta. So sine of theta, I didn't need those parentheses. The sine value is the y value. Okay, the y value. And on this part of our unit circle, all the y values are positive, except for in here at exactly 0 and exactly pi. We don't want that because we'll be dividing by 0. So let me rephrase to make this strictly less than, strictly less than. So 0 is less than y is less than pi. Otherwise, we're fine. And in fact, it's going to be positive on this interval. Great. Then, let us do some trig foo. So, ka, to, a. The sine equals the opposite over the hypotenuse. The cosine equals the adjacent over the hypotenuse. The tangent equals the opposite over the adjacent. And what we're interested right now is some right triangle, an angle y, and we want the sine. I don't know what the negative sine of y is, but I do know that cosine of y equals x from up here. So if the cosine of y equals x, that means that the adjacent over the hypotenuse is x. So if I make the adjacent side x and the hypotenuse 1, then I'm golden. And it could be, maybe this is 2x and this is 2, maybe this is 3x and this is 3, but as these sides change, they will change in proportion to each other. Alright, then I just have to find the other side. You'll notice this is very similar to the sine. I'm not going to do the arithmetic again, so you can just take my word for it that this side is the square root of 1 minus x squared. Then, to get the sine of y, I have to do opposite over hypotenuse, which would be the root of 1 minus x squared over 1, or just sine of y equals square root of 1 minus x squared over 1, or just 1 minus x squared. And we need, for our derivative, 1 over the opposite of the sine of y. So, the derivative of the inverse cosine is 1 over the square root of 1 minus x squared, but it has to be negative. So I have negative 1 over the square root of 1 minus x squared.